Good morning, children. Welcome to the social session. Children, in the earlier class we tried to understand the difference between weather and climate, and today we learn about humidity and precipitation. Humidity and precipitation. Of course, these two terms are not new for us because these are part and parcel of atmosphere. These are the two important elements present in the atmosphere. They are also called as atmosphere variables. So when I talk about humidity, children, you know it very well. In the previous section, like hydrosphere, we have learnt about the water cycle. So in this water cycle, evaporation takes place, and due to that evaporation the water gets evaporated and forms as a water vapor, and they rise up and they form into the clouds. You know these all things. So we have learned the interaction between the hydrosphere and atmosphere in the previous lesson. What I would like to tell you is, so this water vapor is a very important component of the atmosphere, and in most places the amount of water vapor in the atmosphere varies. In some places it will be very high, and in some places it will be very low. So because of the water vapor there will be a change in the weather pattern. So the weather also changes depending upon the water vapor present in the atmosphere. In many places in winter it will be dry and cold. Have you experienced that? Even in the winter season we also experience the same. It will be very dry and cold, and in such places our skin may be cracking. So we use the lip balms for lips. It cracks, isn't it? We use the lip balms, we use the oil for our skin, and we use many other moisturizers. So combined with the high temperature, it is the water vapor that makes you feel sultry and sweaty during the summer season. Exactly opposite to the winter season. In the summer season, due to the high temperatures, you feel sultry and you also feel sweating. Lot of sweat comes out. So when it happens, we try to say that it is very humid, or the humidity is very high. So what does it mean? Not all places are similar in this respect. Some places may feel very dry, like deserts will feel very dry, and the moisture, water vapor in the atmosphere is derived from the water bodies. You know it, due to the evaporation from the water bodies, the water get evaporated and it forms as a water vapor, and this happens because of the evaporation from the water bodies and because of the transpiration from the plants. We have learned different ways through which the water reaches into the atmosphere. The process through which the water turns into vapor from the water bodies is called as evaporation. Transpiration means the plants give away this water into the atmosphere. It is called as a transpiration. Even human beings also give away some water vapor into the atmosphere. That's called as a exhalation. Even ice gets directly turned into vapor. That we call it as sublimation. These all are the processes through which the water vapor gets present into the atmosphere. So here we need to remember that in high humidity our sweat doesn't get cool or cool us because it cannot evaporate, and in low humidity we also feel more thirsty. So remember those particulates, you learned about it in earlier, that particulates which are present in the atmosphere, the dust particles, small fine dust particles, they are called as particulates, which make the sky look like blue in color or sky look like orange in color, is because of the particulates. So these particulates, you remember them. So we express humidity not directly, but using the concept called as a relative humidity. What is this relative humidity actually? So in order to understand this relative humidity, first let us understand what is humidity. Humidity means the amount of water vapor present in the air is called as humidity. I repeat once again. The amount of water vapor present in the air is called as humidity. And what is the instrument used to measure this humidity? It is a hygrometer. The instrument used to measure the humidity is a hygrometer. Now the concept of relative humidity is most important in order to express how much humidity is present in the atmosphere. So this is experienced, or this is expressed as a ratio between two things. This relative humidity is expressed as a ratio between two things. What are those two things? Let us try to understand. The first thing is how much water vapor, the maximum water vapor the air can hold at a given temperature and pressure is the first thing. How much water vapor, okay, water vapor, how much maximum water vapor that air can hold at a given temperature or pressure. At a given temperature or pressure it can hold, maximum temperature it can hold is the first thing. Second thing is the actual amount of water vapor it holds at a given temperature. What is exactly present? The actual amount of water vapor present at a given temperature. The ratio between these two things is called as relative humidity. Now I will explain you what are these two things actually. For example, imagine at a given temperature, that is at 20 degrees Celsius, the air can hold 80 grams of water vapor. Let us imagine at a 20 degrees Celsius, 80 grams of water vapor it can hold per a cubic meter of the air. Per every cubic meter, 80 grams of air, water vapor it can hold. This is the first one. It can hold 80 grams. Whether it is actually present? No. What is actually present? At that temperature only, the water vapor actually present is only 40 grams. How much it can hold? 80 grams. How much is present? 40 grams. So the ratio between these two is expressed as relative humidity. How much it can hold and how much it is present. The ratio between these two is 50%. 40 grams out of 80 is 50%. The relative humidity is 50%. Hope you understood this example. I repeat once again. The relative humidity means the relation between how much of water vapor the air can hold at any given temperature and the amount of water vapor actually present at given temperature. The ratio between these two is called as relative humidity. For that, we have seen one example. At 20 degrees Celsius of temperature, a 1 cubic meter of air can contain 80 grams of water vapor. It can contain, but how much is present? Only 40 grams are present. So here the relative humidity is 50% only. So this is how we can understand. And relative humidity increases with decrease in temperature or addition of the water vapor, and relative humidity decreases with increase in the temperature. When the temperature increases, the relative humidity decreases, or there will be a decrease in the water vapor. So this relative humidity is called as the ratio between the amount of water vapor it can contain and the amount of water vapor actually present in the air. So the ratio between these two is called as relative humidity. So it is the critical temperature at which the saturation level is reached is called as a dew point. What is dew point is? It is 50%. Once it reaches 100%, that means if the air contain 80 grams of water and the air at any given at this temperature it can contain only 80 grams and present is also 80 grams, then the relative humidity is 100%. Then it is said to be reached as a saturation point. What it is called as? Saturation point, or otherwise it is also called as dew point. So this is a point where it leads to another mechanism called as condensation. I hope you know it. Condensation means the water vapor turns into water. The water vapor will turn into water. That process of turning the water vapor into water is called as condensation. It happens at this dew point. So you might have seen the drops of water outside your house early in the morning, or it happens when the 100% relative humidity, and this is called as a saturation level, or otherwise when you take out a bottle from your refrigerator and pour that water into a glass, outside the glass, okay, what happens is the condensed water, the vapor turns into water. That's called as condensation. Condensation is exactly opposite to the evaporation, as it involves the conversion of water vapor into the water. It turns into the droplets of water or the crystals of ice. It depends upon the temperature. If the temperature is below 0 degrees, then automatically that directly gets converted into the crystals of ice. Crystals means pieces. Sometimes we experience the ice cubes falling, the crystals of the ice also falling. Isn't it like rainfall? So it is when the relative humidity exceeds 100%, the excess water vapor turns into the gets condensed and turns into the droplets of water, and this droplets of water, the further decrease in the temperature, it no more can hold that water droplets, and it keeps on depositing onto the surface, and that another process we call it as a precipitation. So humidity leads to the condensation and condensation leads to the precipitation. So let us imagine that at 20 degrees Celsius, let us imagine the air can contain 49 grams of water vapor per a cubic meter, but the temperature got decreased to 10 degrees Celsius. It can hold only 40 grams of water, but how much is present? 49 grams of water are present. So this excess 9 grams gets condensed. That means it gets turned into the water vapor. So the kind of condensation happens because of the dust particles that also gets attracted water molecules from the water vapor in the atmosphere. This causes the condensation becoming more denser, more thick of the water of the vapor into the droplets, and millions of these droplets appear together as different kinds of clouds. The clouds which we see are because of the particulates and because of the water droplets, and these clouds as they cold enough, they may also contain ice crystals. If they are cold enough, they may also get converted into the ice crystals. As I was telling you, snowfall, ice cubes fall is because of the temperature. If it gets the condensed water still gets more cool, then that gets even into the ice crystal. And clouds are classified as different types on the basis of their forms and on the basis of their heights. Especially, for example, we have cirrus clouds which are called as high level clouds. At high level you find these clouds called as the cirrus clouds, and cumulus clouds at middle level, and the stratus clouds at the lower level. And you also have nimbus clouds, which are the rain bearing clouds. Okay, these clouds, depending upon the form and depending upon the height, they are classified as a cirrus and citrus, cumulus, stratus and nimbus. So let me tell you these clouds. Cirrus clouds are the high level clouds, and next level clouds are the cumulus, and third level clouds are the stratus, and fourth level clouds are the nimbus. All these clouds doesn't cause the rainfall, but the nimbus clouds are called as the rain bearing clouds. Rain bearing clouds, they are called as rain bearing clouds. So when condensation, and these are also the vertical clouds, nimbus clouds are also called as vertical clouds, and with condensation the droplets get heavy and fall on earth as a precipitation. So the precipitation is actually a Latin word, and which mean fall headlong or to plummet. Falling vertically is called as precipitation. Okay, precipitatio, it is derived from a Latin word called as precipitatio. In the form of rain, the precipitation occurs. In the form of snowfall it occurs, and in the form of hail. And if these droplets condense very close to the earth's surface, these droplets are lighter and we get fog. Early in the morning we find fog, isn't it? Like smoky. So if it is very near to the earth's surface, it leads to the fog. Okay, but these clouds leads to the rain bearing. Tomorrow in the class we shall learn about the forms of the precipitation, children. We have different forms of precipitation. In tomorrow's class, let us learn about it.